In this video, we're going to look at problems for relative velocity in one dimension. So let's look at a scenario in one dimension. We've got a person walking at 15 kilometers per hour and is passed by a cyclist traveling at 30 kilometers per hour. How fast does the cyclist appear to be moving, observed by a stationary bystander and by the person walking? Okay, so let's look at question A. Now in question A, the bystander is not moving at all. So all they're going to do is see the cyclist moving at the speed that is mentioned in the question. So basically the bystander will see the cyclist moving at 30 kilometers per hour. Okay, so let's look at B. In this case, we're going to see what's happening, how the person walking observes the cyclist. So in order to help us doing this, let's write down the vectors. So here's the vector of the person walking, 15 kilometers per hour. And here's the vector for the cyclist, 30 kilometers per hour. Let's put a diagram in so we can help us identify which is which. Okay, now we know that they are traveling in the same direction. Now, if they're traveling in the same direction, up to 15 kilometers per hour, they'll both have the same speed. So basically what's left over is what the person walking will see the cyclist traveling at. So if we take 15 away from 30, we see that the person walking sees the cyclist traveling at 15 kilometers per hour. Now let's put this down as an algorithm. So we've got the vector of the cyclist relative to the walker equals the vector of the velocity of the cyclist relative to the bystander minus the vector or the velocity of the walker relative to the bystander, which will be the same. So WRBS is walker relative to the bystander. So now if we resolve these as if the walker is stationary, we then have to have that negative value. That negative value would mean that we take it away from 15, so it would be 0. So we get VCRW equals the VCRBS minus VWRBS, which is basically 30 minus 15. So the vector of the cyclist relative to the walker is 15 kilometers per hour. Thanks for watching.